So what I've got here, all right, this branch I got, I'm just going to start right here. I mean, it starts way up here, but I'm at this point right here I'm explaining the antelope part. All right. So I figured there has to be, because I found a lot of evidence that in between we went from an antelope stage, or the horse with the hooves, to the marsupial, okay? Because Pan, chimpanzee and Pan, the half goat, half man in myth, this is where Pan would be. And it would be where antelopes stand up, all right? Where they became marsupial in nature. Now, look at the kangaroo here. Look at this guy. Look how much like an ape or a human it looks, This is the buff kangaroo. Okay, now look at a koala's hands. Look at this. See how much like a human it looks, like it's evolving into a human's hand? The thumb isn't going to end up moving up here to be a pointer finger, and the thumb will end up moving up here, and then the feet on it, look. You see what I'm saying? So, on here, I got the femur. This is the femur on a horse, okay? Here's the femur on a kangaroo, all right? Then here's the tibia, the shin and all that. Here's the tibia. Now here's, on the horse, this is how the horse's looks, okay? But this is all going to become a foot, okay? And that's why a kangaroo's foot is so large. See? Now it looks like this became the toes, okay? That's why we have toes, because that keratin right here was hooves at some point, okay? And the way the legs work here, this whole part right here became a foot as it started to stand upright. But it still couldn't give live birth because the hips weren't fully developed. It was still in a premature stage. You know how babies look like this? Their legs are always bent for a while until they start walking and straightening up. Well, in macroevolution, it mirrors our conception. Literally, it really does. And there's something that happens. I don't know what it is, but every 3 million years something happens that, like a gene or something, is passed. All right. So I figured there has to be something that is hooved, but it's a marsupial. Because it'd be a transitional stage. Lo and behold, there is. The bandicoot and the bilbies. So there is a hooved marsupial. So I think that I'm actually onto something here. And this isn't just the half of it. It's just all with the pan and all that stuff and it just fitting in here. I think they knew evolution. And they talked about the titans. Well, that's what I did. I traced everything to the largest animals on Earth. All the largest animals. And you can see an evolutionary path about how they work. Like it goes from the whale. See? It goes... Okay, there's the manatee. That's another mammal in the ocean. Okay? Then there's the walrus, which is a pinniped. It's like the amphibian version of a mammal, The fish that walks on land, oh, no, there's no fish that walks on land. You know how people are always talking about there's no fish that walks on land? Look, it doesn't have to be a fish that walks on land. It can be a mammal that's fish-like, It's a pinniped. The mermaid, so to speak. And when I looked up, I tried to look up manatee ivory, okay? There's something about the manatee, there's got to be ivory. I think they have ivory bones, but it always came up mermaid ivory. So the manatee and the mermaid has a connection somewhere in Greek, all right? Anyway, so the live bearer, a whale, which has a 4-chambered heart, passes genes to get onto land, all right? Now the closest relative to it that we know is the hippo, all right? And the hippo is an even-toed ungulate, and it's related to odd-toed ungulates. All right. Now, the largest animals are also gray. So that would be the live bearer, which is the whale, passing some genes, which end up evolving onto land, the hippo. Then it's still got its gray, and it's still got ivory, by the way. And it's the elephant. And at some point, after it's the warthog also. Now, we're related to pigs that's actually on another thing, but we're related to pigs like 60-80%. We're 80%. We're related to bovine, so we're like 82 or 85% related to pigs, I believe. But it's crazy, all right? So if we're that close related to them, and even in odd-toed ungulates are the hooved animals, and that's what I was explaining a while ago. So at some point, the hooved animals decided to stand up, and I looked that up, and lo and behold, there's all kinds of Greek that talk about antelope standing up and Pan and all that stuff. So it's like, it's crazy. And you can look up and see the antelopes. They walk on 2 hind legs. So at some point I figured, well, this is when animals are starting to try to be bipedal, the mammal The mammals want to be bipedal. So at some point, it still can't give live birth in a bipedal position, but it's got to transition to the bipedal position, and give premature live birth, which is a marsupial. It gives birth to a little zygote, and then it carries it in a pouch. And then at some point, the marsupial, the kangaroo, because we know it's a real close cousin to apes, evolves into apes. I mean, there's transitions in between. All that's gone. I mean, we're not going to find every fossil. We found like less than 1% of the fossils ever made, less than 1% of fossils even fossilized, But we can see these codes, these transitions. We can see these transitions in nature. And if we do the DNA, we can actually prove that the whales do not evolve mysteriously into the water. Like, get this. All right, now they got whales evolving from a four-legged animal, okay? Now, we know mammals came about after the last extinction 66 million years ago, all right? So between 60 million years ago and now, this is when mammals rose, all right? So where did this guy come from to be able to evolve into whales? Where did it come from? They literally have it popping into existence and then evolving into the water, whales, and jumping back in the ocean and becoming whales. And this animal is literally a tenth of the size of a whale. So it literally evolved into something way bigger than itself. When we know by the laws of thermodynamics, the cellular stability is not there to be able to evolve into something that big. Look what happens to us when we get acromegaly and our body starts getting real big. It kills us. Only people with a specific gene that just is a large person can, that's fully proportioned properly, But this, I believe, is where we get acromegaly genes from, the whale and our large predecessors, the gray animals, before they grew hair. Now get this. All right, now we know all of these gray animals have ivory. Even the warthog has hair and ivory, okay? Now the rhino has a horn that is made of hair, okay? It's not ivory, it's hair. So at some point, this is where we transition and start growing hair. The keratin becomes hair instead of ivory. We lose the ivory. And that's why the warthog has ivory and pigs don't. And they're bald. They have a little bit of hair. They're starting to grow into it. And the rhinos, there's woolly rhinos. And they lost their ivory at some point. So whenever the next thing evolves, the next largest animal evolves, is going to have hair, and it's going to have horns on its hair, and which that is actually the giraffe. And the giraffe is in the odd-toed or the even-toed ungulates. There's like over 270 species, and they're related to cows, and we're like 80% related to the bovine. So we are related to whales. So at some point, we're related. All the mammals are related. Everything with a four-chambered heart that gives live birth. You have to remember, that's how you have to reduce it. And even all these animals have a lot of the same teeth. We even have around the same amount of teeth as like a giraffe and other animals. So it's crazy how you can trace it back using the dentistry, basically,